Hello?
No, not yet.
No, the other one? Thanks. So we seen yesterday some aspects of the ZSA project. The project itself, it's quite large. And as mentioned yesterday by Strad, it touches upon almost every layer inside the Zcash client. Yesterday, we've seen some aspects regarding changes required to the protocol and to the circuit. Today, we will see some aspects regarding to the changes in the Zcash node itself. In addition, we prepared a demo that anyone can download to its own computer and to run it locally. So let's talk about some components of the ZSA project. First of all, we have the zips. The zips are the technical proposal itself. It was partially reviewed by the Zcash Foundation and by the ECC, and the overall technical proposal is solid. There might be some detail fixes required, but the overall proposal, everyone who reviewed it thinks that the overall is solid. Later, we have the implementation of Orchard ZSA, meaning the changes that we did to the Orchard protocol to implement the zips. We consider it stable. It is based on the latest Orchard version, 0.5. And it will require some integration work later to really integrate this into the client. Next, we have a circuit. The circuit is unoptimized. The circuit is part of the Orchard ZSA protocol. It has both a documentation and an implementation part. You can see it. These are clickable links. You can click whatever is relevant for you. In addition, we have the circuit, the optimization stage for the circuit. We started with some early exploration. We are going to define proper benchmarks, and we're going to optimize the circuit. Yesterday, we saw at least one optimization that we done already to the circuit, but optimizing the circuit, we consider it an independent mini project that we will be starting doing soon. Also, we have a PR to Halo 2 with some small additions required to support the functionality of the circuit. And then we go up in the stack. So, for example, for Zcash node encryption, we submitted our initial proposal for the changes. We got some feedback from ECC, and we are waiting. Actually, Zcash node encryption is blocked by other aspects. So except ZSA, there are other things that are happening, and there are other changes that ECC and the Zcash Foundation are doing to improve the Zcash node. So in part, Zcash node encryption is blocked by other changes. So we are waiting for some changes to happen, and then we will improve our implementation of the Zcash node encryption, and we will submit it again. And finally, on top of all of this, we have the Zcashd node. There, we have changes to transaction structure, changes to node management, changes to the RPC, and changes to the Zcash CLI tool. So what we are going to show you today is a demo where we basically ignore the fact that there's going to be a network upgrade. We prepared an end-to-end demo where everything seems to be working, but we ignore the fact that, for example, transaction structure is completely different than what we expect the transaction structure will be after a network upgrade. We basically changed the Orchard part and extend it to be Orchard ZSA, ignoring the fact that future network upgrade will change both the transaction structure, node management, the RPC changes, and everything. We consider this as an alpha version of the ZSA project. And now I would like to ask Alexei to describe some of the changes to the Zcash D node. Please, Alexei.
Yes. Hello, everyone. Last talk for today, and I guess many of you mentally already in the pool, but first let's dip our toes into something very different, and namely code and RPC changes. So basically the interface, how wallet developers, application developers will be interacting with ZSAs. Our design principles, just to understand how we tried to make it, we wanted to reuse existing functionality and concepts as possible. We don't want to reinvent the wheel. We want to be as close to original protocol, but also we want to isolate because we don't want to introduce new security problems into existing code base and existing interactions. And also we don't want to change the interfaces that you are already using to interact with Zcash D. And we try to write as much Rust code as possible, not only because it's way cooler, but also because of the reasons that we already highlighted during this conference several times: security, maintainability. So it should be relatively obvious already. And again, we already touched that on one of the panels. That we actually had to change 6 different modules inside of Zcash. Most of them are written in Rust, namely Orchard. That's the place where probably most logical changes are sitting at the moment. Also Libra Zcash, Halo 2, we need to change it a little bit. We changed the circuit. Constance had a nice talk about that. Test vectors, obviously, because now everything looks a little bit different. And Zcash D itself, which is probably the biggest chunk of work, especially time-wise. It's partially in C, partially in Rust. Let's dig deeper into that. As Pablo already mentioned, currently we integrate our work into V5 transaction format, which is not obviously the way to go forward, but for now it gives us an opportunity to learn, to experiment, and to see something and try it in practice. So basically, as a main carrier of ZSA, we use Orchard bundle. And that's exactly the same Orchard bundle as you know, but to all the Orchard nodes, we add asset base. And what it is, we will talk about it a little bit later. And also we have a new bundle. It's a way how you introduce new asset on the network. You need to issue the asset. So just a few points. First of all, it's a plain text, so everybody can see what you are issuing. But it follows the same node structure, and you can do the same commitment as in normal Orchard nodes. So it allows you to actually use these nodes later as a normal Orchard nodes. So yeah, more in the zips, and we move forward. To issue stuff, you need to have a key that basically shows that you are the person who is authorized to issue that, to create more assets of the type, for example. And the way how we treat the key, it's exactly the same way how you treat a normal Orchard key. So it's the same hierarchy, the same process, and it also allows you to reuse some interfaces that we already have in Zcash D. Asset base, as we discussed, it's basically identifier of an asset. That's a point that we derive from issuance key and asset description to get unique asset identifier that you can later use to do things. Also, there is a special identifier for a native node, but it's not really important at the moment. And when you issue, you can also set finalization flag. It's just a flag that shows you that this asset can be no longer issued to create a limited supply of it. So it can be, for example, used when you create something non-fungible. You just issue one item of asset, like not in 1.0, but like in 0.00001. And so you can use it basically as NFT. Or you can say that there are only thousands of something, and no more can be created after that. Obviously, we have a new RPC command for that. Let's have a look. It's, yeah, no surprise, it is called issue because we use the term issuance to create new assets. An idea is that you use account as a identifier of which key you want to use for that. You have amount of asset, obviously. It's asset description that later will be used to create an asset ID, and the finalized flag that we already discussed. So now we have some assets. It is created, it is on the network, but now you want to actually send it to someone. For that, we use a procedure called transfer. Again, more in zips, but we'll review it a little bit. For now, it is inside the Orchard bundle, but theoretically, the ZSA can be used in any pool, not retroactively probably, but any new pool most likely will have ZSAs. But for now, it's an Orchard. And all the actions, they get this asset base, and sometimes it happens without you knowing this. So for example, if you use old commands to interact with Orchard nodes, in fact, for now in V5, we add this asset ID to the nodes and we operate like if they were ZSAs. And again, obviously for that we have RPC command. Let's have a look at that. Also, nothing new. If you know Z send many, you probably recognize the structure a little bit. We use more or less the same architecture for that. So, but important part, we wanted to separate it into several, into separate command, just because we don't want to change existing commands. So you can still use existing commands to send native nodes, but also there is a new command that you might want to use to send ZSS. So it's quite isolated. You can turn it on and off, do things like that. Yeah, the design of the command is pretty obvious. Who is saying, where you send money, from where you send money, and what amount of money or assets, should I say. And obviously, it just follows the same node structure, the same process that you already have for normal Orchard nodes. So that's basically it. Of course, after you received or sent some amount of assets, you might want to see if they are actually in your wallet, and for that we changed commands to view your balance to see if assets are in there. So this is change of existing interface. We didn't want to create a new command like separate one for just for assets, but it might change in future if you think that is important for wallet builders, for example. But so far, it's just you call get wallet info. You get, in addition to all things you already get, in addition to that, you get map asset balances that show you how many of which assets you have. And so that's pretty much it for the RPC. So that's kind of a theoretical part, but now we have also a practical part. We will show you how easy it is to communicate with that. You probably already have an idea because many of you use these interfaces and you see that the changes are quite small. But anyway, let's do it. Vivek?
Thanks, Alexei. So this is the moment that was like teased right at the start. Can I just, right, so yeah. So yeah, let's get on with the demo. To start with, we wanted to just have a look at what are the installation instructions so that you can go ahead and try this out on your own computers at home. Yeah, we have like our own fork of the Zcash repository, and in that, if you go to the Zcon4 demo branch, then like you can clone our repository and check out that specific branch for like the files that you will need to go ahead. So the installation instructions stay more or less the same as for Zcashd. So the way you have done it, if you have installed Zcashd before, the same way works pretty fine. To like recap that in brief, it's like you first build all the dependencies that you need for Zcashd, and then you build Zcash, including like fetching the parameters if you're doing it for the first time. So yeah, let's now look at the demo. This is like a use case for privacy-preserving prescriptions. So we consider that we have 3 parties here. One is Alice, who's a doctor, and Felix is her patient, who she meets over telemedicine once in a while. And Felix, say, has some some condition that is like managed using like a very specific drug, which can only be got directly from the manufacturer. So yeah, how can we go about doing this in a way that preserves the privacy of Felix specifically? So the idea is that Alice issues a ZSA token for the prescription with the details of the prescription. And first she issues it to herself because the issuance is transparent. So this prescription is just issued by Alice to herself. And then she can later perform a shielded transfer to Felix. Since the shielded transfer is, again, shielded, it preserves the privacy. Nobody can see who has received this prescription from the doctor. Then subsequently, now Felix has the prescription. He can go to the manufacturer and submit, again, with a shielded transfer. He can submit this prescription to the manufacturer. The manufacturer can verify that, like, what were the correct amount of the medication that was asked for by Alice, and then he can go ahead and provide the drugs to Felix. So yeah, if we want to run this demo, we basically will we have a Python file that does the setup for this stuff. So I'm going to run that with you over here. So if we basically just run the Python file, it'll take a little while to run. And what it does is it sets up the initial details for this demonstration, which is like Alice has to issue the address, issue the token first, and then transfer it to herself. Then Felix needs an account, and the manufacturer has an account. So these are the details that the Python file will set up. It basically sets up 4 nodes, 3 or 4 nodes on your PC. And then one node is for Alice, 1 node is for Felix, 1 node is for the manufacturer, and it will generate all the information for that. So it takes maybe, I don't know, a minute or so to run. So I've set it to output all the information on screen so that you can see exactly what are all the details. So you can see that Alice's, basically the port will be picked differently in each iteration of this demo. So you can see Alice's address, the port details, and the wallet details. Specifically, you can see that the asset balances is a new field that is there in your get wallet info. And that's currently empty for everyone. And yeah, that's all the details, the initial details. And this Python file will keep running, and you can use it to input new blocks to generate further blocks to simulate the progression of the blockchain as you go on with time. So yeah, so now we start with the first step, which is Alice issuing the prescription to herself. So we assume that the prescription has a date, today is a date, and the amount of medication that is to be given to Bob. So to do that, the CLI commands would be basically this, that issue from which address, issue to which address, what's the asset description you issue to, then the amount, which in this case, since it's a it's basically a token that you don't want Felix to be able to split and give some part to someone else. So it's the minimum value that's possible, the unsplittable value. And true is the finalization value. So that is basically, it says that this is the last token that will be available for this. So we do this using JSON RPC commands, which is the structure of that is like this. It's similar to what you see on the zcash.github.io/RPC website. But the difference is that it's now the issue method, and the parameters now change to include this information that I mentioned above. So I also have a script here to basically do these things for you step by step in the demo, so that you don't have to copy paste all this information every single time when you're doing it. So if you start this demo, you'll see that it asks that you have already run the Python file first to be sure that you have everything ready. Then yeah, you have this. So Alice issues the prescription to herself. It runs the curl command, as you can see, with the issue method. And this is Alice's from address. And yeah, the asset description over here, and all the details that I mentioned earlier. So that gives you a successful result. And then you can go ahead and, yeah, you need to like generate some blocks. So you generate blocks on the other window with the Python file. And then you can continue, and you get the details that you want to look at Alice's wallet, confirm that the issuance did happen as we claim it will. So if you look at the asset balances now, the asset balances were previously empty. But now if you look at the asset balance for Alice's wallet, it shows a new asset ID over here. It's the asset base value in hex. And you can see that the confirmed balance is now this minimum value that's possible for the token. So yeah, this demonstrates the issuance of the asset, and the asset base is set to this for the purpose of this demo now. So now the next step for us is to, yeah, basically the asset base is defined. And yeah, the next step is the shielded transfer. You transfer the prescription from Alice to Felix. This is now using like the send assets command that Alexei mentioned. That works by like it takes the transfer address of Alice, it takes Felix's address, tells the same amount, and it requires the asset base that I showed you earlier. And you have an optional memo field. So here I'm using the memo field with a signature by Alice of the information, so that later Felix can use that to show that this is something that is truly sent by Alice and not just himself making his own token up and trying to get some more medication. So yeah, curl command again uses send assets and the same parameters that I mentioned above. Yeah, I guess I should point out that the HTTP address here is not like you use a different address. It gets taken directly in the demo. Like it changes based on the port number, basically. So yeah, so we go ahead. You have here that same command written with all the details filled in, like the address and like the from address, the to address, and the asset value and the amounts. So yeah, so that creates. So basically, this is a asynchronous operation in the same manner that send many that already exists is an asynchronous operation. So you wait, and then it gets like until the operation status is completed. So then you can run some blocks to confirm, like to get everything confirmed, and then you can check the balances. So now here I'm checking Alice's wallet, and if you see Alice's asset balances are now back to the empty set because she no longer has that prescription anymore. She's transferred it to Felix. And similarly, Felix's wallet now has the same asset base, the ID. So that means that now Felix has this prescription in his hand. It belongs to him. And now he can go ahead and transfer this to the manufacturer and get the medication that he needs. So the way he will do that is, again, you use the send assets again, same way as before, but now Felix is sending it. So it's Felix's from address. It's the manufacturer's address is the to address, and same amounts. And Felix just repeats the signature that Alice gave him. You can probably have additional information sent as well in the memo, but this is the bare minimum that's needed for this. So curl command, again, pretty much the same. Yeah, I guess I didn't mention that the user ID also changes, and as per the demo, it gets picked in this particular manner with RPC user 0, RPC pass 0 is the username and password. So yeah, if we go ahead now and run that, Felix transferring the prescription to the manufacturer. Again, the script will automatically fill the details for you about the addresses that are required. And yeah, you can generate some blocks to make sure everything's confirmed. And then if you look and see the details of now Felix's wallet and the manufacturer's wallet, you can see that, again, Felix no longer has this asset balance, which is good because you don't want Felix to be able to go again and again with the same prescription. You want the prescription to be generated fresh by the doctor each and every time. And yeah, the same balance is now with the manufacturer. So yeah, this successfully demonstrates the entire process that I had in mind for this privacy-preserving prescriptions. And yeah, that's basically what I had for the demo. And I hope y'all can all try it out, try out different things. You can use I think I have the commands mentioned here. This is the installation instructions again, if you need that later. And there's an appendix with basically all the commands I used. You can you can mix and match these things. This is just one example of the issue command with the way I got the addresses for Alice and Bob and so on. And so you can try out using Felix's address instead of Alice's address. See that there's an error. You can try transferring more than you issued. You can see that there's an error. And you can basically play around with this. You have all the commands and have fun.
So we have one question. Not sure who. Okay, Pablo. With ZSAs, does it mean that individuals can create private tokens or assets on the Zcash blockchain that can be traded like other tokens?
So I'm not fully sure what do you mean by private tokens. You can issue tokens. The issuance is done in plain text, like everyone can inspect what was being issued and whether the issuance was finalized or not. Once the tokens are issued, you can transfer them privately, and then you can trade them and transfer them and use them like any other, basically exactly like Zec. You get the same privacy as you get with Zec, just with the slight difference that every token is unique and defined by asset ID, as Vivek mentioned.
Yeah, to add to that, for example, in the demo, we saw that I wanted the asset to be privately given to Felix, the patient. And so I issued it to myself first, the doctor issued it to themselves, and then transferred it to Felix. So that part stays private. It can't be, it's the same privacy that Zec has.
Thank you.
Thank you.